Dear student, welcome to another video tutorial on programming concept using C. And today's topic is memory allocation of array. Okay, so in our previous tutorial, we have discussed how to write C programs in array and how to initialize an array or how to declare an array. Okay, so today we will discuss about memory allocation of array. Okay, so before discussing, I want to introduce myself. Myself, Niladri Shekhar Pal. I am working as an assistant professor at Computer Science and Engineering Department at Greater Kolkata College of Engineering and Management. The college is under GIS Group Educational Initiative. Okay, and the college is situated at Bangalore. Now, what is array memory allocation? In one-dimensional array, location of element AI can be calculated using the following equation. Okay, so the equation is location of AI. Okay, so if we want to find out the memory location of any element of a array, okay, the formula will be the base address. Base address means the address of the first element plus w into I. Okay, what is w? The base address is basically the address of the first element of the in the array, and w is the word size. It means the number of bytes occupied by each element. That means it depends on basically the size of, suppose it is an array of integer. Okay, so it will take 4 bytes each or 2 bytes each. Okay, it basically depends on the compiler. Okay, so the most compiler will take 2 bytes for storing the integer elements. Okay, so w is the word size. Okay, now, okay, so now it's the row major order. Okay, so we can get the address of any element, okay, by using row measure, okay, or column measure. Okay, so what is row measure? In case of row measure, okay, elements of an array are arranged sequentially, row by row. That means, uh, suppose the all the elements of array in memory location are calculated using row by row. Okay, so thus the element of first row occupies the first set of memory locations reserved for at the array. Okay, and elements of the second row occupies the next set of memory, and so on. And the location of element aij can be obtained by evaluating the following expression. That is, location of aij equals to base address plus wmi plus j. Okay, so base address basically the address of the first element in the array. W is the word size. Okay, that it means the number of bytes occupied by each element. Okay, and n is basically the number of rows in the array, and m is basically the number of columns in the array. Okay, so in case of row major order, elements of an array arranged sequentially, row by row. Okay, thus that means the elements of first row occupies first set of memory locations reserved for the array. Okay, and elements of second row basically occupies the next set of memory, and so on. So if we want to find out the location of element aij, okay, that can be obtained by evaluating the following expression. That is, location aij equals to base address plus w mi plus j. Okay, where base address is basically the address of the first element in the array. Okay, and w is the word size. Okay, it means that the number of bytes occupied by each element. Okay, and n is the number of rows in array, and m is basically the number of column in array. Okay, so let's check how to find out the location of an array elements in an array using row magic. Okay, so as you can see, this is the pictorial representation. Okay, A00 means the first element of the matrix. Okay, so 11, 12, 13, 14, 21, 22, 23, 24. This is the position. Okay, 1 means first row, first column. Okay, 1 2 means first row, second column. 1 3 means first row, third column. Okay, and A14 means first row, fourth column. Okay, next one is 2 1. 2 1 means second row, first column. 2 2 means second row, second column. Okay, 2 3 means second row, third column. 2 4 means second row, fourth column. Okay, and 3 1 means third row, first column. 3 2 means third row, second column. Next 3 3 means third row, third column. And 3 4 means third row, fourth column. Okay, so 1000 is the address of first element. 1002 is the address of second element. As you can see that every element will take 2 bytes. Okay, and the elements are taken as row wise. Okay, so row wise is the address of the elements are incremented. Okay, so after 1000 the next address of element is 1002. Okay, next one is 1004. Next one is 1006. Okay, as you can see that all the elements are address of the elements are incremented by 2. Okay, next 1008, 1010, 1012, 1014, 1016, 1018, 1020, 1022. Okay, and 00, these are the index value. Okay, 00101, 0203. Okay, 10111213, 20212223. These are the index value. Okay, now how to find out these values using the formula. Okay, so as you can see that elements are stored in this manner: 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34. Okay, these are basically the sequences. Okay, how the address are stored. Okay, next, suppose we want to calculate the address of element ARR1. Okay, so you will find out the address of ARR1. Okay, that means this 112. Okay, this address ARR1. Okay, so how to find it? It can be calculated as we know that the base address is 1000. Here you can see that the base address is 1000. Okay, W is 2. That means each element will take 2 bytes of space. Okay. Next one is M equals to 4. That means there are total number of n column, 4 columns. Okay, as you can see, there is 1, 2, 3, 4 columns. N equals to 3 means there are n rows. Okay, as you can see that there are n rows. Okay, and the value of I is 1 and j is 2. As you can see that we have to find out the address of ARR12. Okay, so it is ARRIJ format. Okay, so if we equate it with ARRIJ format, then I will be 1 and j will be 2. Okay, so now formula is location of AIJ equals to base address plus WMI plus. Okay, so if we put the values, that is location 1 comma 2, base address is 1000, W value is 2, M here is 4, I is 1 and J is 2. Okay, so it will be location 1 2 will be 1012. Okay, so this is how we can calculate the address of an element in an array using row measure. Okay, so I am again discussing how to find out. Okay, so as you can see, uh, array elements are given here. 1 ARR 00, 01, 02, 03, 10, 11, 12, 13, 2021, 2223. These are the index values. Okay, 1000, 1000, 2000, 4000, 6000, 8010, 1012, 1014, 1016, 1018, 1020, 1022. Okay, these are all the memory addresses. Okay, as you can see that all the elements locations are incremented by 2 as each element stores 2 bytes of space. Okay, and elements address of elements are incremented, okay, by row wise. Okay, so it does not incremented column wise, it incremented by row wise. Okay, so how the array locations are calculated, like 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34, like this. Okay, so suppose we want to calculate the address of element ARR12. Okay, so how we will do it? We will calculate it as follows, that is base address equals to, here we can see that 1000, the value of W is 2, that means each element will take 2 bytes of space. M is 4, that means number of column here is 4, and N is 3 means number of row is 3. I is 1, J is 2. Okay, that means we have to find out the value of ARR12. Okay, so if we relate it with WARRIJ, then the value of I will be 1 and the value of J will be 2. Okay, so location of A and the location of AIJ, the formula is base address plus WFI plus J. Okay, so if we put the values, base address is 1000. Okay, next W is 2, M is 4, I is 1. Okay, and J is 2. So location of 1 2 will be 1012. Okay, so now we'll do it column measure way. Okay, so in the column measure order, elements of an array are arranged sequentially column by column. Okay, so in our previous case it was row by row. Okay, so in this case it is column by column. Thus, the element of first column occupies first set of memory allocation, okay, reserved for the array, and elements of second column basically occupies the next set of memory, and so on. Okay, the location of element aij can be obtained by the following expression. Okay, so the expression is location aij. Okay, formula is base address plus wnji. Okay, so basically in our previous example, in case of finding using column measure, we have seen the formula was base address plus wmi plus j, but in this case this is the opposite. Okay, so it is wnj plus I. Okay, where, as you know, base address is basically the address of the first element of the array. Word is the word size, that means the number of bytes occupied by each element. Okay, n is basically the number of rows in array, and w is and m is the number of columns in array. Okay, so in column measure order, an array arranged basically sequentially column by column. Okay, element of first column occupies the first set of memory locations reserved for the array, and the elements of second column basically occupies the next set of memory, and so on. The location of element aij can be obtained by evaluating the following expression, that is location aij, okay, equals to base address plus wnj plus I. Okay, so in case of row measure order, the formula was location aij equals to base address plus wmi plus j. Okay, so here it is opposite. So here base address is basically the address of the first element in the array. W is basically the word size. Okay, that means the number of bytes occupied by each element. In case of integer, if the array is consists of integer, then it will be W will be 2 bytes. Okay, if it is float, it will be 4 bytes, like this. Okay, it basically depends on the compiler. Okay, what will be the size. Next, n is the number of rows in array, and m is the number of columns in array. Okay, next how to find it. Okay, so this is our example. Okay, so as you can see that in our previous example, in case of row measure, okay, we have this is the initial 1000. Okay, in case of row measure, this incremented by row wise. Okay, the location of the address were incremented row wise, but in case of column measure, it will be incremented column wise. As you can see that the incremented happen column wise. So yeah, like this. Okay, so yeah, 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34. These are the numbers. Okay, AR00 is the position, index values of the first 0th row, 0th column. AR01 means 0th row, first column. AR02 means 0th row, second column. AR03 means 0th row, third column. AR10 means first row, 0th column. ARR11 means first row, first column. ARR12 means first row, second column. ARR13 means first row, third column. ARR20 means second row, zeroth column, 2 1 means third second means third row first column, ARR 2 means third row second column, and ARR 3 means third row fourth column. Okay, so this is how it will work. Okay, as you can see, the addresses are incremented by 2 column wise, that is 1000, 1002, 1004, 1006, 1008, 1010, 1012, 14, 16, 18, 20, 22. Okay, so this is how it will work. Okay, so let's check how to find it. Okay, so this is how it will work. So first 11, then 21, then 31. As you can see, it will happen column wise. Okay, next 12, 22, 32, 13, 23, 33, then 14, 24, 34. Okay, so all happens as column wise. Suppose we want to calculate the address of element ARR12. Okay, so how we'll do it? So here the base address is basically 1000, W is 2. Okay, 2 means each element of row, each element of an array will take 2 bytes of space. Okay, as the elements are integer. Okay, M is 4, that means number of column is 4. N is 3, that is number of rows is 3. Okay, I is 1 and J is 2. As ARR, we have to find out the address of element ARR12. Okay, so if we equal it or compare it with ARRIJ, then it will be the value of I will be 1 and J will be 2. Okay, so the formula is location AIJ equals to base address plus WNJ plus I. Okay, so here base address is basically the address of the first location, that is 1000. W is basically the word length, that is here is 2 because all the elements are integer here. Okay, next N is basically the number of rows. Okay, J and I are the values. Okay, of which we have to find out the element address. Okay, so if we put the values here, that is location 2A12, it will be 1000 plus 2 into 3 into 2 plus 1. Okay, so base address is 1000 here, 2 is the value of W, N is here 3, J is 2 and I is 1. Okay, so if we calculate it, the address will be 1014. Okay, so as you can see that 1 2, the address is 1014. Okay, as you can see this is 1014. Okay, so this is 1014. Okay, so this is all about row measure and column measure. Okay, so let's once again discuss this. Okay, from first. So in one dimensional array, the location of element AI can be calculated using the following formula, that is location AI equals to base address plus W into I. Okay, where base address is basically the address of the first element in the array, W is basically the word size. Okay, it will depend on which value you want to store, that is integer or float. Okay, and it also depends on the number of compiler. Okay, each compiler may vary it. Okay, now row measure order. Okay, it can be calculated using row measure and column measure order. Okay, So in this method, elements of an array are arranged sequentially, okay? That is row by row. So the elements of first row occupies basically the first set of memory locations reserved for that array. And elements of the second row basically occupies the next set of memory and so on. Okay. So the location of element aij can be calculated, okay, by evaluating the following expression. So the formula is location aij equals to base address plus wmi plus j. Okay, so this was the formula. Okay, so if we put these values, okay, we can get all the values here. Okay, so the base address basically the address of the first element in the array. Okay, w is basically the word size, that means the number of bytes occupied by each element. N is basically the number of rows in the array. Okay, name is the number of columns in the array. Okay, so this is an example. So these are the values 11, 12, 13, 14, 21, 22, 23, 24, 31, 32, 33, 34. Okay, so here it all will be happen row wise. Okay, so 1000, 1000, 2000, 4000, 6, 1000, 8000, 10, 1000, 12, 1000, 14, 1000, 16, 1000, 18, 1000, 20, 1000, 20. Okay, so this is how it will work. Okay, so this is how it will place. This is 11, 12, 13, 14, 21, 22, 23. Okay, 24, 31, 32, 33, 34. Okay, so as you can see that all the elements are stored row wise. Okay, so suppose we want to find out the address of this value. Okay, so ARR 1 2, what we will do, base address is 1000, W is 2 here, M is 4, N equals to 3, I equals to 1 and J equals to 2. Base address means this one. Okay, 1000. W means here elements will store, each element will store 2 bytes of space. M equals to 4, that means here number of columns are 4. N equals to 3, okay, that means number of rows are 3. Okay, and I equals to 1, J equals to 2, because ARR 1 2. Okay, if we relate it with ARR IJ, then I will be 1 and J will be 2. So the formula is location aij equals to base address plus wami plus j. We have put all the values here. Okay, so the address is location 1 2 equals to 1012. Okay, so let's do it using column measure. Okay, so in column measure, elements of an array are arranged sequentially, column by column. Okay, first elements or the first column occupies basically the first set of memory location reserved for the array, and the element of second column occupies the next set of memory. Okay, and so on. The location of element aij can be obtained by the evaluating the following expression. Location aij equals to base address plus wnj plus I. Okay, so in our previous case, in case of row measure, the formula was base address plus wmi plus j. But in this case, wnj plus I. Okay, Here base address is the address of the first element in the array. As you know, W is the word size. Okay, that means the number of bytes occupied by each element. N is the number of rows in array, and M is the number of columns in the array. Okay, so this is the problem. As you can see that here the elements are stored in column wise, or memory allocations are done column wise. This is 1000 to 1004. After first column completed, we will move to the second column. This is 1006, 8, 10. So second column complete, we will move to the third column, 12, 14, 16, and after completing third, we will go to the third one. Okay, so it is 18, 20, and 22. Okay, so this will, so the elements are sequenced as 11, 21, 31, then 12, 22, 32, then 13, 23, 34. Okay, and then 14, 24, 34. This is how. Okay, so if we want to find out the values, okay, so it will be ARR1 2 will be find out. Okay, so base address here is 1000, W is 2, same, M is 4, N equals to 3, I1, J2. M is basically the number of columns, N is number of rows, I is 1, J is 2, as we will calculate or equate it with ARRIJ like this. Okay, so the formula is location AIJ equals to base address plus WNJ plus I. Okay, so if we put the values here, okay, so the address will be location 1 2 is 1014. Okay. As you can see, in case of row measure and column measure, totally different addresses are given. Okay, so students, this is all about memory allocation. Okay, hope you have understood. Okay, if you have any doubt, any query, you can write on the comment section. Okay, or if you have liked my videos, you can subscribe to my channel, or you can visit my Facebook page, that is www.facebook.com/digital classroom Niladjipal. Okay, so students, thank you for now. See you in the next video tutorial. Thank you.